All right, why don't we dive in? The number of people joining has slowed down, so we'll go ahead and do this. And then obviously, I'm sure there will be more folks who will join as the session goes on. So thanks everybody for joining us for our second day of the CIP, the Competitiveness Improvement Project Informational Workshop. It's great to have you all here. Thank you to Heather again for reminding us of being a little bit better. So I'm Baring-Gould from the National Renewable Energy Laboratory and have been running CIP for a good number of years. And so I'm hosting this event, though most of the work is being done by Brent Summerville, who's taking over the CIP project as we go forwards. Quick land acknowledgement. NREL, and specifically the Flatirons campus where I sit, is on the land of the historical lands of the Ute, Arapaho, and Cheyenne people. So thank you, Heather, for reminding us to do that acknowledgement.
And I know your hair's getting longer, but you're still he, him, right?
I'm still he, him, Yep. Again, as we said yesterday, and I'll do this quickly because not to take too much time, but we don't have lots of time for around the room introductions and things of that nature. So please kind of enter into the chat here your name, kind of gender designation, company, a little bit of information about your organization. If you would like to put your own land acknowledgement in, please go ahead and do that. And then something of your interest around CIP. For our European colleagues, the land acknowledgement is something that we're trying to do more of because of all of us, all of our organizations sit on lands that were historical lands of the people who were here before us. And so making acknowledgement to that, partly to address the wrongs of that all of our ancestors have in taking over those lands from those people. So it's an important thing here in the United States to be thinking about. Also, Guru put started a nice little connection web or Excel spreadsheet, Google Sheet, to allow people to put kind of a bit of information about their organizations. I'll drop that into the chat so that people could go ahead and do that. There's about 30 people on there now, so it's a good way to kind of get information and put it in one place. And because it's a Google document, it will live into the future. So a good place to do it. I'll also have a slide on this in a minute, but we had talked about LinkedIn website and or LinkedIn site, and we said that we were working on it. Well, it came through yesterday, so there is now a new LinkedIn thing, and we'll see that in a little bit. Again, all of this is means to help us coordinate a little bit more around the globe about CIP and moving this kind of industry forwards. So without further ado, here's the agenda for the conference or for the workshops over the next couple of days. And today we're talking a lot about standards and then the design review process, which again, for a lot of our proposals are incorporated in there to allow kind of stage gates within the design process. And this is something that we've implemented, these kind of design review and evaluations, as we've become more developed within the CIP process. And it is actually really a good thing for both us and for the companies to go through. And it's really there to make sure that you are ready. So under the CIP process, in all of these cases, we provide you some funding to be able to kind of pull paperwork together to get to this point of this design review, prepare for it, and then you sit down with a bunch of folks, a lot of them people here at NREL who have been doing distributed wind work for decades, and we get to sit down and talk through that, what you're doing and whether you really are where you are, provide recommendations and things of that nature. And then at the end of it, there is a decision about whether we move forwards. And I'd have to say that in no point has that decision not been mutual. So I think that's really important. We've had a number of cases where we go to that design review and we talk through wherever you are in the project, and everybody comes to the conclusion that, hey, I'm not ready for the next step. And that's a good way to kind of stop, take a step back from what you were planning on doing, and think about what the next steps are. And that's better than running down this path that you're not going to be successful at. So I think it is a good process and a healthy process that we go through. So we'll get into a lot of that today. And then tomorrow we'll talk about contracting, some of the design tools, and have some time there for additional considerations and discussions. We'll have breaks and stuff for questions. And then lastly, again, and I'll get to this, well, we have office hours set on Friday, and that's because as part of the dialogue today, we don't want a lot of detailed questions around kind of specific projects or your specific technology or things of that nature. That's what these Friday office hours are for. So we certainly encourage questions, encourage discussion during these workshops. But if you really want to get into the details about your technology and where you are in the CIP process and things of that, please don't hesitate to email Brent, and we'll set up a little time on Friday to at least initiate the conversation. And then if we want to talk more about it, more about your technology, we can certainly do that as we go forwards. So just to be clear, any of the information that we cover today or during the workshop in general are based on experiences for the last rounds of CIP, all 10 of them, but are not necessarily and should not be assumed to be consistent with any future potential offerings. So again, based on the past, we actually aren't sure exactly what's going to happen in CIP for the notice that we have put out for a CIP release starting in the new year, so January, February timeframe. But we can't answer questions specifically to any potential future CIP solicitations, but we can certainly provide guidance based on the last ones. Once a proposal has been released, if it is released, at that point, NREL and DOE staff cannot talk about it. So now is your opportunity to really get into any details about your technology and about how that might fit into CIP. Thoughts about previous proposals that you have submitted that haven't been successful or that have been successful and ways to improve it. We can talk about all of that stuff now. We cannot once a solicitation has been released. If you have any questions or want to be put on the distribution kind of formal contracting questions or want to be put on the list, there's an email there, and then check out the website because we keep posting more information there. Again, we'll try to get to all the questions, so please type them into the chat or raise your hand, and we'll be happy to go through them. Again, not a time now for detailed conversations about your technology. We can follow up more on that as we go forwards. And then please use the chat, the spreadsheet, and then the new LinkedIn group for kind of further communications and stuff like that. Also want to quickly announce the Distributed Wind 2024 conference, the business conference and lobby day. And I'm not sure if Mike Berge is on, but Mike, if you're on, please unmute yourself if you'd like to talk a little bit about DOEA more generally and then the conference.
Sure. Thank you very much, Ian. I appreciate the time.
Of course.
So in addition to my day job at Berge Wind Power, I'm president of the Distributed Wind Energy Association, and DOEA is the trade association representing the behind the meter and community wind parts of the wind industry. We split off from the American Wind Energy Association a number of years ago so we could have an unalloyed voice for policies that will help build the businesses in our industry, which are somewhat different from policies that the wind farm people need. Every year we get together for a day and a half conference and 1 day lobbying event, and then NREL and DOE typically spend an afternoon in industry discussions. So For 2024, that will be February 26th through 28th. The conference will be the 26th and 27th. The industry discussions with the federal government and the labs will be the afternoon of the 27th. And I think this is, I would like to, and personally invite all of you to attend. Many of you who are on this call have attended in the past. Those of you who haven't, I can tell you this is your one opportunity in 2024 to learn about the opportunities that have been presented by the bipartisan infrastructure law and the Inflation Reduction Act, which have been transformative. We have tremendous momentum within the industry for sales and for research support from the federal government in particular, and the industry is, after some tough years, I must say, growing quite well. So this is your opportunity to come make contacts with existing industry people, maybe network, meet the whiz kids from the national labs like Ian and Brent and his colleagues, and really get immersed in the business opportunity. So I just want to, if you go to the DWEA website, which is distributedwind.org, it's at the bottom there, you'll find links to the registration, the hotel. We have a nice rate. It's in Arlington, Virginia. Great suite hotel. And I can tell you this is a great event that will profit your company. And I hope to see you there. Thanks, Ian.
Certainly. Thank you, Mike. I just second that. I mean, it is, there are other conferences out there, but there are none in North America that, let alone the Americas in general, that really focus on this distributed wind space. So it's a small conference, but very good. And if you're in this field or have products or things of that nature that you want to look at the U.S. distributed wind market around, this is the one conference a year to attend. So highly encourage people to attend. Mike did say that we're having a kind of an industry discussion on the afternoon of the 27th, and that will be focused around strategic planning. So we're pulling that together, but the Department of Energy is working to update its strategic plan for this market sector. And so the dialogue for that afternoon will be around this strategic planning and kind of the vision going forwards, given the new policy changes that Mike referenced, and what the Department of Energy could and should be doing to help support the industry going forward. So that'll be the focus of that afternoon session, and more info to come. Lastly, the new LinkedIn group right there, and Brent will put that in the chat. So encourage people to go and sign up. Again, this is not going to be a location where we're going to be putting out weekly highlights of great things that are out there or things of that nature, but really focused around how do we improve collaboration and communication around the Competitiveness Improvement Project. And so please don't hesitate to use this to kind of inform this community about your companies or questions that you have, or if you want to put out your shingle as a company that can do modeling work or design work or something of that nature to help companies bring products, this is a place to do it. So don't hesitate to join in there, and then we'll see what kind of dialogue we get. So without further ado, well, I guess any questions or thoughts that people have about this kind of reflections on yesterday, happy to answer those questions, as well as questions about CIP in general or what we're going to be talking about today. People were very quiet yesterday, not many questions. So definitely, I'm afraid that I might have scared people off from asking questions, and I hope that's not the case. Still no questions.
I'll say I had an email question from Joe and Joe Kelly, and it's a good question, so I thought I'd bring it back up. And the question is, if we are to focus on only one of the topic areas, how much detail should be shared on the follow-on topics to show a comprehensive plan? And so my answer was basically that I think this will be made clear when you look at the merit criteria in the request for proposal documentation. But for most, if not all the topic areas, you will want to explain how you got to where you are, through designing a prototype, the evolution of the design, the calculations, modeling, and testing, and where you're going, such as the pathway to testing, certification, manufacturing, and commercialization, or your target market. And I think a lot of this is articulated in the RFP merit criteria. So showing, looking back, showing the work done to make you ready for the effort, and showing where you're headed. We like to see some evidence that you have a viable product that will eventually make it to the market. So I hope that these are part of the proposal. You don't have to go into great depth, but yes, we do like to see the articulation of the path ahead. So thank you for that question, Joe.
Yeah, proposals that don't talk about certification don't get very far. So you have to really show that path to certification. And that just means you've been thinking about it.
Right.
And you are doing designs, you're looking at your design based on the certification requirements that are out there. Or if there aren't, if you're airborne wind as an example, and there aren't really strong, this is the certification that I'm supposed to meet, that you at least talk about that and what you're doing based on the absence of certification, the kind of modeling and things that you're doing, so that you believe the product that you will have will be commercially successful, but then will meet whatever kind of requirements you see as being applicable.
So I have a question regarding same thing. Like, let's say what we are doing is like, it's a generator is like a new design, turbine is a new design, and possibly we will go with tower also as a new thing. So some of the components will be off the market, which is like inverter, grid connector, and all those things. So if I see at my project, it's like a new turbine, new generator, and new things. So can we go with like all these components and apply it only for certification or research or development, or how do we categorize it? Because I don't want to like apply everywhere and then get rejected because, hey, you are not there or something like that. So that's like a situation I am in. So how would we tackle this if we want to go ahead with that?
Yeah, so I think the answer is twofold. The first one is the session that we will launch into right now with Brent, talking about the kind of the current certification requirements that are out there. Your design, even if you're using off-the-shelf components or if you're using new stuff, has to be able to pass the certification requirements that Brent is going to talk about in a second. And that's either the ones in the United States or the international ones that the US recognizes. And so you just need to make sure that you understand what those requirements are, and that as you develop your product, that you are planning, you're kind of designed into those requirements, you're considering those requirements in your design, and that that you have a plan to go through that testing protocol to make sure that the components are. For stuff that's off the shelf, power electronics as an example, or even blades for turbines that you're planning on purchasing from an outside vendor, you want to make sure that those outside vendors have gone through the certification requirements that are kind of identified or out there, whether that be UL or something of that nature. And again, you articulate that in your proposal. So it's clear that you are thinking about those certification requirements as part of your design process. And that's whether you're building things from scratch or whether you're purchasing things from the market.
Okay, thank you.
No, certainly. Any other questions? All right, hand it over to you, Brent, to delve into this good question about certification.
Okay, great. Thank you, Ian, for kicking us back off.
Oh, my pleasure.
Thanks everyone for coming back to day 2. I'm going to talk about some small and medium wind turbine standards and certification. And then Shawn Martin from ICC-SWCC will join me. And then after that, we'll get into the fun world of testing from one of our veteran test site operators, Dean Davis with Windward Engineering. And then we'll take a break and finish the day with some design review or design evaluations. But let's talk about standards. So, I used to work for SWCC, so I benefited greatly from working for a certification body and really getting deep into the world of conformity assessment or certification. And this is a standards talk here, but the reason we're concerned about standards is we're headed toward turbine certification. DOE, NREL, and the whole industry have been behind this since a long time, but it really peaked out, and we had a collective voice around 2009. We got our own standard, our own certification body, and we're really committed to trying to certify a small wind technology, small and medium. But certification is the formal process through which an independent organization performs what's called conformity assessment of a turbine to establish criteria and industry standards. So yes, you have your own job of designing a turbine to the standards, which are there to help in the design process. And then when you get to the point of certification, you have to convince the certification body and work together that you've done everything and performed field testing according to those standards. And it's sometimes not black and white. Therefore, you need a third-party certification body to work with you and make some calls on granting certification, or need more information, or please redo this, or this does not pass. And it's an iterative process that that benefits you in the long run of having a product that's been through the engineering rigor. It's important for consumer protection. Uncertified technology can cause a black eye in the industry. We know that all rotating electromechanical equipment that's subjected to the weather events can have issues, but there are internationally developed standards that do our best job of assessing the engineering that went into the design and performing field testing to verify and validate some of the assumptions and in the field. So it helps prevent some unethical marketing and false claims that could cause some damage to the consumers. It also allows the turbine manufacturers to demonstrate that the turbine model in fact meets performance, durability, and quality standards, allows apples to apples comparison between the ratings of the power, sound, and energy output of the turbines that went through the certification process. Funding agencies and utilities, whoever's interconnecting with and providing funding for these distributed wind applications, have greater confidence that the projects will be most likely to be successful after receiving public funds. And some incentive programs use certification, if not most or all, for eligibility requirements for their program. And here you see a consumer label for a turbine that's gone through the certification process. The state level incentives have been in great flux, but just pulled this text out from recent IRS notice of proposed rulemaking for Section 48 commercial tax credits. And finally, after much help from the Distributed Wind Energy Association and the Department of Energy, we've got an updated list of eligibility for these proposed eligibility requirements for these tax incentives. And so the good news is they have requirement that the small wind turbine must meet the quality standards of the AWEA standard 9.1, IEC standards that apply to distributed wind, small wind, and they've added, they're proposing to add the new ANSI ACP 101-1-2021 small wind turbine standard and subsequent revisions. So that's good news. We've been pushing for IRS to keep things updated per the standards, and now they have a proposed rulemaking text to do so. So this is really what drives the motivation to certify your turbine, not only for these reasons shown here, but to just be eligible for, to have your customers be eligible for these incentives. So where are we with the small wind turbine standard? Well, it all kicked off in the very end of 2009, where the industry worked hard to create our own national standard, AWEA standard 9.1. And it has been utilized by testing organizations, turbine manufacturers, certification bodies, incentive agencies, and consumers for many years. The standard did go through a revision cycle through AWEA, but there was some flux and change within the AWEA organization. ANSI remanded that revised SWT-1 standard that came out in 2016. And then after that, AWEA became ACP, American Clean Power Association. And then the industry worked with ACP, including NREL, Distributed Wind Energy Association, and other stakeholders to develop this new latest, greatest ANSI approved ACP 101-1, which came out in late 2021. So that's their current small wind turbine standard in the US. And here I'll pull this out of the distributed wind market report from Pacific Northwest National Lab, and it shows the number of new certifications per year. And the standard came out in late 2009. SWCC was stood up in 2010, and then certification really took off with 2011, 12, and 13, bringing up the number of certified small wind turbines to about 13. Another bump up took it to about 17 in 2018. And then, as Mike Berge noted earlier, it was a rough few years for the industry. Some of the manufacturers focused elsewhere, and certifications expired, and we settled back down to now, I think, 9 certified turbines, and so picking back up again. But back to that ANSI ACP 101-1 standard, something new. These are all new things in the standard. The scope used to follow the scope of the international standard IEC-61-400-2, which would be 200 square meters of rotor swept area in modern turbines with a low specific power. That these days that's 20 or 25 kilowatt machine. But we increased the scope to apply to turbines up to 150 kilowatts of peak power for this standard. So that was a sizable increase. It's broken up into sections, and it's not a standalone standard. In other words, it points to and incorporates the suite of IEC standards put out by the International Electrotechnical Commission, where groups of experts work all the time in the background to develop and maintain the standards for many, many products, including wind energy. So it'll say, go do a power performance test per IEC 61-400-12-1. The small change here is that since the anemometer and the turbine tower under test are so close, that we see a site calibration values where you have an anemometer to measure the wind, and you put an anemometer where the wind turbine will be, and you compare those wind speed measurements to get a correlation factor. We see those factors really high in the 0.98, 0.99 range, meaning that the measured wind speed is pretty similar, very similar to the wind speed at the turbine. We decided to save a little money here and make site calibration not a hard requirement in this standard. The acoustics are per IEC 61-400-11, which has an NX for small wind. They define as 100 kilowatts. And we made the uncertainty calculation of the acoustic measurements an option to save a little more money. The biggest change is in the duration test, where it had many requirements over a large range of wind speeds, and it took many months to complete this test, costing lots of time and money. So we abbreviated the requirements to show reliable operation through 10 hours or 1,000 hours of power production, including 10 hours and 15 meter per second winds and above, saving lots of time and money from this test, or the test required for certification. Safety and function testing is done per IEC 61400-2, and not a lot of change there, except for you to make sure you demonstrate peak power when measuring power across the large full range of wind speeds. And the design part of -2, we increased the turbulence intensity assumption from 0.18 to 20%, from 18 to 20%, limited the design class to class 2, and or S for special, and then limited the simplified loads methodology to turbines up to 30 kilowatts and not recommended for turbines that are greater than 10 kilowatts. And added some model validation requirements based on size categories, which we'll look at in a second. A new definition is micro wind turbines up to 1 kilowatt that have limited requirements, and moved reference annual energy, sort of the consumer rating of kilowatt hours produced at a site, at an assumed site, moved it up from 5 meters per second to 6 meters per second to level the playing field when comparing wind energy, expected energy with other technologies. And that the standard does have an annex covering conformity assessment, sort of the helping the certification body with some guidance, and it adds a field inspection requirement, monitoring 5 turbines in the field for 3 years, so that there's a clear eye kept on these initial deployments, with a conversation between the OEM, the manufacturer, and the certification body on any issues with those turbines in the field. So a little table at the very back of the standard, which is for sale on the ACP site. I can dig up a link later and put it in the chat, but we've got categories here. Under the 150 kilowatts, there are 4 categories of sizes, from micro wind up to 30 to 65, and 65 to 150 kilowatts. So here you see that there are limited requirements for micro wind turbines. You do a duration test, a power performance test, and a safety and function test, and you get a label, but you don't have to do a blade test, an acoustic test, or loads testing to validate your model, because there's no hard requirements for structural design at that level. For this level and beyond, we see increasing measurements for validating the aeroelastic model. We see varying requirements of the simplified load model across the sizes. And likewise, down here, the testing requirements vary across the sizes, where blade testing is not required for micro, but is for all the others. And when you get to the largest category, it is recommended, but not required to do accelerated fatigue testing. There's lots of details behind the behind all of the changes made within the standard, and they're captured in this report. For example, the what if analysis on if we were to implement the changes to the duration test to some past tests, it would take the average test period down from 10 months to 4 months, saving lots of time and money for removing a lot of requirements that did not show a lot of value, and boiling it down to a shorter test to assess the operation, normal operation of the turbines. So here's our current list of certified turbines from the PNNL market report. The Berge XL 10 and 15, the Everready Kestrel, EOCycle S series, the Hivot Colite or the high volt machine, the DS3000, the Primus turbines are now operated by Rise Energy. The SD Wind 6 kilowatt and the SkyStream is back on the list. Several companies are in the process here, but these are all certified to the old WEA 9.1 standard, except for the Air series, which were certified to the IEC standards. Okay, so that was the current state of certifying a small wind turbine up to 150 kilowatts in the US. We've reached a pretty good space where we have certification body and we have a standard, and things have been going for a while. The other option, and as you heard about a bit yesterday as we talked about the topic areas, is type certification through IEC-RE, which stands for the IEC System for Certification to Standards Relating to Equipment for Use in Renewable Energy Applications. So it has a system for wind and solar and marine technology. It's a global certification system, so it's intended to be usable for global markets. Instead of a national standard intended for that national market, it's a global system intended to be recognized around the world. The IEC-RE develops these operational documents, ODs, which describe the requirements of the type certification to the relevant IEC standards. This replaces the old -22 standard, which described type certification. And they have two routes. One is through operational document 501, which is wind turbine type certification for wind turbines of any size per the scope of IEC 61400-1. If you go look at the IEC-RE website, you see over 100 valid type certificates listed, and these are multi-megawatt turbines with very large rotors. Our CIP type certification efforts are limited by our 1 megawatt cap, as we are focused on small and medium size technology. The other route that IEC-RE has developed is small wind turbine type certification through operational document 554-1. And this follows the scope of -2, which is currently up to 200 square meters of rotor swept area. I don't see any small wind turbine certificates as of yet to OD 554 on the IEC-RE website, as this is a relatively new path. And IEC-RE is unique in that it's a self-contained scheme. Member bodies, which are the countries that participate in the program, pay fees to join, as do member certification bodies, testing laboratories, inspection bodies, and other members. For example, if you go to the IEC-RE website, you see their list of member certification bodies that are actively offering type certification in the IEC-RE system. You don't see, so we've got two different pathways here. In the US, ACP 101 is your standard if you're up to 150 kilowatts, and the ICC-SWCC is your certification body. If you're looking at a larger turbine outside that scope, or for a global solution, you can go the route of IEC-RE. And this type certification on the small wind side, both ACP and IEC-RE both point to the International Small Wind Turbine Standard IEC 61400-2. Currently, the scope is up to 200 meters squared rotor swept area. I am the convener of the maintenance team for this standard. Maintenance teams are called MT, and this is for -2, so it's MT2, and we are actively working through the 4th revision of this standard. It kicked off in May of 2023. The current standard is stable and will not be touched until the very end of 2025, so we are targeting 2026 for a new -2 standard. It took a long time and a lot of discussion, but the Technical Committee for Wind Energy, IEC-TC88, has approved a scope increase of the -2 standard from the existing 200 square meters to 1,200 square meters rotor swept area. And within that expansion, we have 3 size categories. Micro are turbines up to 5 square meters, small 5 to 200, so kind of the existing -2 turbines, and then medium turbines, which will be 200 square meters up to 1,200 square meters rotor swept area. So the Carter 300 kilowatt is about 1,000, almost 1,100 square meters, and that's the very top end of what we see as small or medium wind turbines that are smaller in scale and have a variety of archetypes such as passive yaw, upwind, downwind, and we folded them into our standard. A lot of this came from input from an IEA Wind Task 41 that met as an international cohort to discuss the issues in distributed wind and published recommendations on potential standards changes for distributed wind. Also, we contracted with Rick Damiani and Dean Davis on air elastic modeling for distributed wind turbines, and they've put forth some recommendations for improvements there, as has Dr. David Wood on improving the simplified load model. So we're going to switch over to Shawn Martin now with ICC-SWCC to talk a little bit about what they're up to as the active small wind turbine certification body here in the US. So Shawn, you should be able to share your screen if you wish and take it from me.
All right, great. Thank you very much, Brent. It's a pleasure to meet with all of you. I'm going to be going over a bit of information about the certification process that SWCC operates in the US using primarily ACP 101-1. Many of you may know SWCC from our previous name. It was independent up until about 2017 when it joined the ICC-ES organization, or International Code Council. ICC-ES is the branch that certifies a wide range of building products. So small wind certification fit neatly into there, and we're happy to have that alongside some of our other renewable energy certification programs. So I'll be talking a little bit about the approach that we use. It's if you've worked with SWCC in the past, this should be relatively familiar, although for some of you this may be new. I'll be talking about something called preliminary reviews. We use preliminary reviews as a means of starting the certification process, and I'll explain a little bit why. Before I get into that, though, I just want to make sure that we're on the same page as far as what certification is. I do find that sometimes there's some confusion among manufacturers regarding the nature of certification. The focus is so heavy on the testing phase at the beginning that they maybe don't quite understand the big picture of how it fits in to the product long term. So the first stage is, of course, the application and evaluation stage. That's the stage where we as a third party, meaning we have no role in the design or production of the turbine, would evaluate the turbine to some set criteria. In this case, ACP 101-1 or IEC 61400. Primarily what we're looking at in this particular program is assessing compliance with minimum requirements for things like life, health, safety, and durability. And this is key, we're also determining consistent performance ratings that are standardized conditions to allow different turbines, the performance of different turbines to be compared on an equal basis. So that's the first stage, and that's always the stage that manufacturers really focus on, because that's where we're examining the testing reports, that's where the testing is taking place, the analyses, all that. At the end of that stage, certification is granted or not granted based on the determination of the certification body. Then, as Brent mentioned, there's a field monitoring stage. This is a relatively new stage introduced by ACP 101-1. And I believe, if I understand correctly, Brent, it was a trade-off between an extended duration test in AWEA 9.1. So what they did is they cut the duration test a little bit, but the trade-off was we have more field monitoring. And that's where we work with you for about 3 years to monitor the performance of 5 units in the field. Just keep an eye on them, see how they're doing, see if it lines up with the evaluation stage. And then after that, we have a period, during that, we have a period of monitoring and maintenance. So what makes certification different than just testing? Testing is a snapshot. It is an assessment of the performance of a sample or samples, usually just one sample for turbines, at a point in time. Certification examines your examines your ability to continue to produce turbines that are consistent with the performance and aspects associated with the one that went for testing. So your clients want to be sure that they're producing, that they're able to purchase a turbine that is functionally similar and comparable to the one that you tested. So that's where we do quality management system assessments, also known as factory inspections, which are usually beloved by manufacturers, but we essentially evaluate your quality management system to confirm for the customer that you can indeed produce reliably products off your production line that have similar performance to the one that you had tested. Otherwise, the performance values you obtain are only valid for that one particular sample. So that goes on, and generally that inspection is conducted once every 2 years. So whereas testing is a once and done snapshot in time, certification is an ongoing process that assesses your ability to continue to produce a compliant product. Let's talk a little bit about the program. So as Brent talked about, there are different categories. ACP 101-1 has categories that are established between 0, I guess, theoretically, and 150 kilowatts of peak power. As he mentioned, there are several categories which are listed below. In that range, 0 to 150, we look at safety and function testing, power performance testing, acoustic performance, and structural design and load evaluations. The requirements for those scale with the size of the turbine. And that was the matrix that Brent was kind enough to share with us. For turbines in the range of 150 to 300 kilowatts, we do offer what we call medium wind turbine certification. And in that range, you can essentially be assessed to one or all of the following 3 standards. So that's 61400 12-1, 11, and 1 for their respective topics. So that's what we offer presently. So let's talk a little bit about what's in and out of scope. Oftentimes there's some confusion on this part as well. So first of all, our certifications cover turbines. We're looking, and when we say turbines, we mean things like the blade, shafts, gearboxes, bearings, so on and so forth. You can read down through. Notably, there's a couple of things that aren't included, and Joe Sposey yesterday touched on electrical listings. That is under a completely different standard. We are asked this fairly frequently, but electrical safety listings are not included in ACP 101-1 or 61400 standards. Now, we do look at them, but only in the context of durability overall, and in terms of the standard power production ratings that are generated as a result. So we are not looking at electrical safety. We are also not looking at that for, we're not looking at that for the generator, the inverter, or any power conditioners, or the associated controls. The other thing to note is it does not include the towers. That includes the turbines and any, the foundations and any tilt-up devices or mechanisms. The ACP 101 and 61400 certifications end at the mounting point to the tower. So it's important to understand what's in and what's out. Okay, a little bit about the pathways, the ways you can reach certification, and the way that preliminary reviews, which I'm going to delve into now a little bit, factor into that. I've denoted them here with A, B, and C. So A is a new certification. That is a turbine that has not been tested to the standard yet. We start that out with something called a preliminary review. We look at your plan for the product. We confirm that the product is in scope, and we help you to identify the specific tests that are applicable to your product. And then the testing would proceed at an appropriate testing organization, not including us. And that's a key point. SWCC does not do testing in-house. You would need to work with a qualified testing organization to do that. Another way to go about it is if you have another regional certification, let's say MCS, for example, from the UK, or some other regional certification in another part of the world, class NK from Japan or whatever it might be, we would conduct a preliminary review there as well. But the focus would be, instead of looking at the testing that you're going to be doing, we'll be looking at the testing that you did to date and the structural analyses and things like that. So we would be looking at that, and we would be determining how much, if any, of that testing can be applicable to a certification under the SWCC schemes. Sometimes the entire thing can be met by existing testing to standards like 61400. Other times it might be that some of the testing can contribute to it, but you might need to do something, what we usually call gap testing, which is addressing the items that are not addressed or not sufficiently addressed in your existing test reports. And if that's necessary, you would then do that testing, and then we could do the evaluation. Lastly, in some cases, you might come in with an AWEA 9.1 standard certification to the older version of the standard. And again, same thing, we would review it, the circumstances of it, and determine whether certification can be granted based on the information contained within those reports and analyses. So all of those are potential pathways, but they all begin with something we're calling preliminary reviews. So let's talk about what they are a little bit more clearly and get into the specifics. We do preliminary reviews for several reasons. Number one, first and foremost, we confirm eligibility for SWCC certification. We don't want to waste your time or anybody's time if it turns out that your turbine is not within the scope of the certification program. So that's the first key point right up front. Is it eligible? If it is, we move to the next steps. We might look at any existing test reports that you may have or analyses to see if we can use those. If you don't have them yet, we might look at your test plan and look at how you're going to be doing that, where you're going to be testing, what organization will you be testing with, and what kind of testing configuration do you have in mind to qualify with the standard. We want to get you get confirmation early that you're off on the right track. We would then establish the scope of the testing that's necessary. As we talked about before, the testing requirements scale with the different categories, with the size. And so we would work with you to identify specifically the tests within the standards that would be required for your particular turbine, because they do vary based on size and other criteria. We would vet your testing organization. If you haven't done your testing yet, we would vet it if you have done your testing. Either way, we review the testing organization's suitability to see if the data is acceptable. But if you haven't done it yet, we would vet the site and the organization's qualifications, and we would review your general test plan for consistency with the relevant standards. And then lastly, we would provide you a quote to give you a sense for what the certification services would cost. Why do we do all this? Well, as you know, certification testing for turbines is very lengthy, and it's not as long as it used to be under the previous standard, but it's still pretty long, and it can be somewhat expensive. So the key is we want to be sure that there's a common understanding of what the requirements will be. The last thing we want is for you to come to us with a test report, say, great, here's your test report, we're all done, let's get it evaluated and see if we can get it certified, and have us say, no, I'm sorry, this test report won't work. That's the worst case scenario. Nobody wants to see that happen. So we want to identify the specific tests that are necessary for your particular turbine and what your certification goals are for that turbine. We try to educate you on the process and procedures. We want you to understand what they are up front so that you don't waste time going down blind alleys. For example, sometimes people come to us and say, well, can I do my testing in a wind tunnel? No, the standard does not allow for that. The standards only allow for testing in a real world scenario. So if you were to begin down that road, begin testing in a wind tunnel and bring us the results, we would say this is very lovely, nice graphs, everything, but we can't use it. And that would be, again, unfortunate. And then we're also here to support programs such as CIP in just assessing your readiness to begin undergoing certification. And then lastly, we want to help set expectations for what the timeframes and the budgets will be for certification so that you can go into it in an educated way. So these are the steps that are involved with a preliminary review. First of all, you submit an application, indicates your interest in seeking a preliminary review, and it includes something called a configuration description. It's a detailed form that you fill out that tells us all about your turbine, any tests that you have done, any analyses that you have done, and what you are seeking as far as a new certification. We then go through a process of information gathering. There's a list of other submittals I'll go over in a minute that we'll be looking for from you. There'll be some back and forth. We'll review that material, ask a lot of questions, and then we'll review it with the SWCC Certification Commission. This is a panel of third-party wind turbine experts with a tremendous amount of experience, and they review that together with us and the staff, and we reach a consensus on whether or not your submission does indeed qualify to move ahead with certification, or if it's not ready. We do charge for it. We charge $3,000 per preliminary review for one turbine. If you have additional related ones, it's $1,500 for the others. You might say, why? It's actually a very time-consuming process. So we essentially have to charge for our time to cover what's involved there. Fortunately, NREL does have funding, a grant program available for that, and I'll describe that in a minute. People always ask how long it will take, and it is almost impossible to predict. It can range in time from a few weeks, if you really have everything pulled together and you're ready to go, to several months or even years in some cases, as folks realize that they need to go get more information or make more plans. Sometimes they'll go away and you know, for example, go find a testing organization. They may not have had one when they start. So it really depends on the availability of information. The kind of submittals, what are we looking for? What information will we need from you? Well, first of all, we'll need a basic information about the configuration. So we'll ask things like the power configuration, the basic geometry, some of the elements. We'll look for drawings, schematics, images. We'll list all that out for you. We'll need information on your testing, whether it's already been completed or whether you plan to do it in the near future. You'll need to either provide us with existing test reports or your plans for conducting testing, who you're going to work with, ideally a test plan, something of that sort. We'll need to evaluate that. So it's very important, if you wish to move ahead with a preliminary review, you haven't done testing, one of your first steps should be identifying a testing organization or laboratory that you're going to be working with. And then strength analyses, if you've done them, great, and you're able to share them with us, we can take a look at them up front. Or if you haven't done them yet, basic information on what you plan to do, what type of analysis, simplified load model, aeroelastic. If it's aeroelastic, what kind? Are you going to use Hawk 2? You're going to use fast? How are you going to go about doing it? What is your plan? And specifically, which items are in the turbine are you planning to evaluate and how? As I mentioned, there is a grant available to help offset the costs associated with this. So our thanks to NREL and the DOE for providing funding for to help support preliminary reviews. They recognize that a preliminary review helps to prepare manufacturers to go through the CIP program and to support certification. So they've been kind enough to provide that. It's available through the end of next year. It covers the entire cost of preliminary reviews for those applicants who qualify. and who are submitting turbines for preliminary review in the size range that we mentioned. And at the end of it, we do provide the outcome, a checklist that we go through to NREL to document it, just provided to them for their review and documentation purposes. But other than that, the process is otherwise unchanged. There's no difference. So,
And
big
Shawn,
thank you.
I did put that link in the chat just now.
Really appreciate it. Thank you very much. Couple of suggestions. Number one suggestion, don't wait till the last minute. Sound like I'm talking to my teenagers here, but that's very, very important. Please do not wait until the last minute. If you're going for CIP funding for certification and you haven't done a preliminary review, haven't even started a preliminary review, please don't contact us the week before and say that you'd like to do a preliminary review. We won't be able to do it in that time frame. Number two, have a plan and a partner for testing. If you haven't figured out who you're going to work with for testing and so on and so forth, I strongly recommend you begin by talking with them first, or at least at a similar time, because their involvement is extremely helpful in conducting the preliminary review. This one I can't emphasize enough. Know the standards, please. It would be very helpful if going into certification, you have a sense for the standard. So if you haven't read through the standard, haven't perused it, you don't know what the requirements are, strongly recommend that you at least skim the standard so you have a sense for what you're going to have to meet. Next one is just plan for the field monitoring phase. Just know that after this, if you receive certification, congratulations, that's great, but we're going to need to monitor 5 turbines in the field for 3 years. I think I got that right. Hopefully I didn't get that backwards. So you might want to be thinking about identifying them earlier, because we're going to be asking for that right afterward. And we realize that you can't turn on a dime and identify them right away. This is probably my biggest one. Can't emphasize this enough. Please, if you haven't, don't expect to conduct your validation testing at the same time as certification testing. And by that, I mean, when you begin certification testing, that should not be the first time that you've erected a turbine and put it out into the field. In the real world, for real world testing with instrumentation, some people try to do that. They try to combine validation testing with certification testing, and it usually ends badly because, and that leads to my last one, you should expect the unexpected. I cannot tell you how many times the complete unexpected happens during testing, during certification. That's why we do it. Testing in the real world just doesn't, it can't be replicated in a laboratory. We can get close. We can do a lot of really good work there, but there's really no substitute for real world testing. Last but not least, here's my information. You can reach me here. If you're interested in pursuing a preliminary review, please, by all means, reach out to us sooner rather than later, and we can get the ball rolling and find out if you would qualify for funding under the NREL grant for that. And with that, I'll end there. I don't know, Brent, is there anything else I can touch on there?
No, that's great, Shawn. Thank you so much. I'll say, are there any, we're a little behind schedule, but not really, but we have a time for a question or two if anyone has any right now, before we move to Dean Davis. I think I hear something, but it's really faint. I've got a question in the chat for discussion with Dave Snowberg, and I'm going to clarify a couple things probably after the break when I get my answer together. If there aren't any burning questions right now, I think we can switch to testing. I started my career in field testing, and I think it's a very eye-opening part of this process. You spend a lot of time with turbines in the field, watching them interact with the environment, and it's quite fascinating. So if you want to engage Guru with the certification body, you contact them directly and say, I'm interested in your services. How do we begin? So as SWCC just presented, they have an NREL-funded preliminary review step as their first step, and it's that $3,000 fee is waived through a partnership with NREL. So it's a pretty low barrier to get started with certification, at least start the conversation with the certification body. So if you're interested in certification to ACP 101 in the US, you would contact active certification bodies offering that. The only one known to us is ICC-SWCC. If you're interested in that global certification to serve many markets, you would reach out, you would connect with IEC-RE. And all of this is really to become eligible, have your turbine customers have be eligible for the many incentives that require certification. All right, thanks. Well, Dean Davis, are you ready to tell us about test sites and certification testing before we take a break today?
Think so.
Okay.
Can you hear me okay?
Hey, hear you great. Do you want to share your screen?
Yeah, let's try.
All right, thank you very much. Thanks, everyone.
Is that working?
Sure is. Thank you, Dean.
Let's see. Okay. Yeah, so some of mine will go over what Shawn just described as well as what Brent did earlier, but maybe a little repetitiveness in the situation is okay. So yeah, I'm going to talk a little bit. It's interesting because Brent and Shawn are coming from the certification body side, and I'm kind of the guy that's maybe collecting this data and putting together reports and presenting it to them. So that's kind of the role I've been playing. But just wanted to share you some of the details around that. So just quick background. I guess I started this journey in 1990 as an undergraduate, mechanical engineering, built and tested my own basic wind turbine there. Kind of then moved to Utah to work with Dr. Craig Hansen on some computer modeling. That was in the early 90s. Started windward engineering with him in the mid 90s and pretty quickly wanted to do some validation of our models. So started the test site in Spanish Fork. This turbine is a few years later after setting up the test site, something that Robert Price would remember fondly, I hope, back in the day. After testing a whole bunch of other people's turbines, I thought, you know, I should design my own wind turbine. And that started in the early 2000s. Here's a picture in 2006 where we had designed a 5 kilowatt, started a company, Endurance Wind Power, and took it to market. Endurance made it about 10 years with 4 different models of turbines, but eventually did kind of fall to that lull in the industry that we had around 2016. And then with the fall of Endurance going bankrupt, I kind of shifted back into my testing role and work on this on the site. And the picture in the lower right there is some of the turbines and activities we've got on the site currently. So again, there's obviously, as we've shown and yesterday and today, there's multiple topic areas of CIP. I'm just going to kind of focus on these 3 testing topic areas. So prototype testing, small wind certification testing, and then type certification. Kind of this has been gone over already, but again, small turbines historically have been less than 200 square meters. Now under ACP 101, that goes up to 150 kilowatt. And then type certification doesn't necessarily have to be for large turbines, but typically it's going to be for larger turbines greater than that 200 square meters or greater than 150 kilowatt. And then I've got some numbers here around kind of what does a CIP offer or bring to the table. You can kind of see some of these numbers. So like for the 2 smaller turbines, 250, 300K roughly, NREL is bringing 80% of that to the table. And then for the type certification, all the way up to $1 million project where NREL would bring up to 800K. And then there's, I think Brent discussed, there's some equations that might lower those numbers. So those are kind of maximum numbers. So what is kind of involved or required in terms of certification? And I'm obviously leaving the prototype testing out, although I think it makes a lot of sense if you were doing prototype testing that you would still follow these testing standards, and really, you know, it's a little bit meaningless to prototype test and not set it up like the standard, because obviously at the end of the prototype test, you might be interested in getting more funding or investors. You want to have data that is, you know, is of quality that is going to be accepted by others, type of thing. So although I'm not focusing on prototype testing, because who knows what the goals of that are, I think knowing the standards, testing to the standards still makes sense under the prototype testing. But in terms of certification, we've got design evaluation, and Shawn went through some of this design evaluation. And then we really have these 4 required field tests. So power, performance, acoustic, safety, and function duration. The type certification, again, you still have the design evaluation stuff, but the tests are slightly different. You still have power, performance, safety, and function, but you have mechanical loads of blade structural. And then acoustic is actually optional. And then there's some additional stuff around manufacturing and a final evaluation. As you guys are probably familiar by this time, there's these IEC-61400-X kind of standards that really relate to testing the wind turbine. So power performance is -12, acoustic is -11, small wind turbine design is -2, large turbine is -1. And then we have these AWEA standards, which historically has been the AWEA 9.1, and then now, as of the last couple of years, ACP 101. There's a mechanical load standard, -13, structural blade testing, -23, and then I think Shawn went over some of these, but there's the ODs and various other standards that can come into play depending on what you're trying to accomplish. Again, if you're, let's say, a manufacturer, you're interested in the certification, you're going to need to work with some certifying body. For me personally, I've worked with SWCC and Intertech, but I believe there's a longer list than that you can work with. So I have UL, DNV, and some of these others. In terms of test facilities, I apologize if someone has a test facility and I don't have you on the map. There's our test facility at Windward Engineering. We're in Utah. NREL has tested numerous small wind turbines to the standards. They're at the Wind Technology Center. UL down in Texas has a test facility. Renew Test is nearby in Pampa, Texas. I wasn't sure if Appalachian State is still doing some work, but I think Brent showed there was a test going on. So it sounds like they're still doing some testing.
Yeah, only Rocky is there with Sunsight at the moment.
Okay. And then I have Intertech here, which was in New York. I asked Joe, is that still up and running? And it sounds like it's not. So that one's not around, although Joe Sposey is the one that set that test facility up and really made it happen. He's a great resource for anyone that's interested in doing testing, and he'll set you up with some other location. And then one that's new to me is Wind Test North America, which is in Iowa. So there's some due diligence, as Shawn said. The certification body needs to be able to trust the data and the reports that come out of a test facility. And how does that work? Well, if you're a accredited test laboratory, I think it's fairly straightforward, like NREL. Just have a lot of paperwork that shows they can trust you. If you're not accredited, then there are some procedures to go through to kind of show that, again, that the testing agency is familiar with the standards and is going to operate within the standards. So there's some quality assurance procedures and manuals, testing related procedures manuals, interview of personnel, round robin. They might give you a data set for power performance and have you use your post-processing to come up with the final results and compare it to what they have. And then a test site visit or witnessing. And it makes sense that, I mean, obviously they need to trust the data and the reports that come out from a testing facility is up to snuff. It's in accordance to the standard and in all ways. And I should mention that although I showed those testing facilities, my understanding is you can still self-test. And I think Mike Berge would agree with that. I think he's done most of his certification testing at his location. So you don't have to go with a test facility. You can do it on your own in your backyard if you want. Same things are all going to apply, that you're going to need to show to the certification body that, you know, that you understand the standards and you're going to follow the standards. So if you were saying, well, we do want to self-test, we want to find a location. Well, I've kind of put together a list of what would be the ideal site attributes. So in general, for all the tasks, you'd like to have regular non-seasonal winds, meaning you don't want to get your turbine up and guaranteed it would work this way, where you'd set it up, and if you had a period where you had no wind, that's basically when it'd be ready to go. You'd sit around for 3 months waiting for a wind season. So ideally you have winds all year long. Favorable zoning and permitting laws, you don't want to get caught up in all that. And then I think nearby resources. I mean, I have lots of resources nearby my test facility, and I use them all the time during tests. I'll run down to Home Depot, or I'll go get a man basket or something. So again, the more you are in the middle of nowhere, probably the more challenging and the more time you're going to need to do your tests. Not to say you couldn't do it. Specifically for power performance, you want unobstructed ground, ideally flat terrain, and you will want some high winds. You know, if you have a site that just never gets above 12 meters per second, that's going to make it challenging to do power performance. Acoustic, a little different. Now you want a quiet site. Not necessary, but unidirectional winds are helpful because you do need to have the microphone set up downwind of the turbine. No nearby reflective surfaces, unchanging ground cover. I mean, I think it's, again, if you're doing it over a relatively short period of time, probably not an issue, but if you had really tall grass sometimes and snow other times, that would obviously affect the acoustics. Duration tests, there, one of the goals is just a lot of power producing winds. Doesn't have to be high winds, doesn't have to be moderate winds, just has to be power producing. I say not extreme winds, but to be honest, I think some gusts and extreme winds is probably helpful. And then this is not required by any standard, but I think some variability in the ambient temperature is probably a good thing to know if your turbine has an issue in the cold or an issue in the heat. I think that's probably a positive thing. In terms of loads, again, you do want those occasional high winds. That's probably where some of your higher loads come from. You know, I could see challenges in southeastern Wyoming where you don't have any calm, where you just need to go out and do some calibration work or fix a sensor or put on a strain gauge. I think regular times of calm wind is nice. And then you do want some variability in the turbulence. And if you actually look at the -13 standard, it in its capture matrix, it wants variability in turbulence. So the ideal test site might not exist, but shortfalls can be mitigated with ingenuity, time, and money. So our site checks a lot of boxes, but in terms of flat ground and unobstructed, it's not. It's a very congested site. So, but we can work around it. So getting into more specific of the power performance, and I start with power performance because I see that as kind of the foundation test, meaning I like to set up my tests for power performance, and then I can use all that same instrumentation for all the other tests. For the acoustics, I can use it for the duration, for the safety and function. So I think, again, I think power performance is kind of a foundational test. And so I would put my Met tower in accordance with power performance. I would set up my instrumentation in accordance with power performance. And this would apply for prototype testing as well. When you are doing power performance for certification, the standard, this is the IEC standard, does have a section around obstacles and how to evaluate those and whether you're going to exclude sectors, so wind sectors. So an obvious wind sector that you exclude is when the wind turbine is upwind of the anemometer. That's an excluded sector. It's always going to be an excluded sector. But if you've got a big building off to the side, that might result in an excluded sector as well. And so the standard goes through those details on how to evaluate obstacles as well as terrain variation on the site and that kind of stuff. So if I had a site that looked like this picture, I would just go into the standard and just say pass, 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 and it would all be good. And I'd know exactly what wind directions are valid, what wind directions are invalid, everything would be simple. Most people aren't going to have a site like that. So they'll be pass on most, but maybe there's a few sectors that are not clean enough or have obstacles in the way, and you would exclude those sectors, and that might not be a big deal, but you kind of just do some evaluation on that. And then technically, there's other sites, which I would put the Spanish Fork site in that category, that just aren't going to pass on paper. And technically, those require site calibration. Although, as I think Brent mentioned, ACP 101 recognized that in a small turbine world, that Met tower anemometer and the turbine are typically not very far away from each other. So even when things, the terrain is varying a little bit and stuff, you can still kind of accept that data. So here's just an example of, and again, this is all laid out in great detail in the standard, where your Met tower should go, how you should set up, the primary anemometer, how much distance below is the secondary anemometer, how much distance from the wind direction, wind vane, where does air temperature go, where does air pressure go, what size booms are supporting all this instrumentation, depending on what tower you're using, how far they should be away from the tower. You can actually have side-by-side setups. This is not that situation where you have the primary and the secondary kind of side-by-side. But again, the standard goes into great detail to describe this all. And as Shawn mentioned, if you own the standard and you're looking through the standard, it's just all laid out. And it's really just follow step by step. And oh yeah, okay, it has to be 4 meters away or something like that type of thing. So on the ground, you're going to have a power transducer typically, and you're going to have your data acquisition system. It could be a Campbell Scientific data logger, or I've been in this LabVIEW world where I have modules that accept the instrumentation or the signals, and then it ends up on a computer. The standard gives you some requirements and a little wiggle room on recommended other channels, but RPM is typical. Turbine status might be another one. Pitch angle might be required if you actually have variable pitch. Wetness, rotor azimuth might be a good one, etc. The image here is just the 3D printing world has been really nice for this kind of stuff, because I can customize gears and stuff and get, very custom sensors that will pick up whatever I want. This is azimuth and RPM. Here, I just kind of wanted to throw something in here around some of the cost of this instrumentation. Now, I haven't gone through these numbers in a few years, and post-COVID, seems like everything's significantly more expensive. So I'm probably on the low end at this point. But again, I just want to throw a little bit of an idea of what some of this stuff would cost. All your sensors are going to end up needing calibration sheets. If you're buying new sensors, you can just request that it comes with the calibrations, or if you have sensors already, you can send them to TransCAD, or there's various calibration laboratories that you can send your instrument to and get calibrations for. You're going to need those calibration constants to set up your data acquisition system. There's uncertainty information in there that's going to be required for your uncertainty analysis. These calibration sheets will end up going kind of as an annex or an appendix in your final report. So they're important in that regard. And I've run into situations where I've been requested to get 17025 certified calibrations versus other times it hasn't been an issue, but you might want to talk to your certification body on if that's a requirement or not. And usually a 17025 is a little more money type of thing. So, okay, so at this point, let's say you've found your test site or you're working with an agency, you've got your instrumentation all set up, you've got your DAC system, and you're ready to start power performance. So what does the standard say in terms of requirements? You know, obviously you can't collect data for 2 hours and then say, oh, I'm done. You have to reach some kind of thresholds to say you're done. So I've got here 2 different scenarios. One, and this is all coming out of the -12 standard, the IEC-12 standard. So technically, if you're in that, and the -12 standard is for wind turbines in general, it's not for small wind turbines. So there is an Annex H that's for small wind turbines. So, and according to IEC, that would be less than 200 square meters. So they want a minimum of 10 minutes in each bin, where the data set is a 1-minute data set, and the bin widths are 0.5 meters per second. And you want to go from 1 meter per second below cut-in to 14 meters per second. And the total data set is to be 60 hours or larger. And then if you're, again, if you're in -12, but not necessarily a small wind turbine, now we want 30 minutes in each bin. Now we're dealing with 10-minute data sets. The bin width is still a 0.5. Low end, 1 meter per second below cut in, and on the high end, it's kind of this complicated 1.5 times the wind speed at which 85% of rated power is reached. And then about 3 times larger data set, they want 180 hours for the total data set. And how long does it take to get that? You know, to get 60 hours or 180 hours? It really comes down to, you know, how many sectors are invalid and how often does the wind come in those invalid sectors. For me, I usually have a very small allowable sectors, but our wind is fairly unidirectional as well. So it's usually not a big problem. So, but again, how much data do you have to throw out because it's coming from the wrong wind direction? And then I think most common, you get your power curve, but you're kind of waiting to get those higher winds. You just need to see how that power curve is going to roll over and how high a wind speed do you need to get to quote, complete this power curve. NREL suggests 3 to 6 months. For me, we can be doing duration testing, which is looking for this 1,000 hours of power production. We can kind of just put the power performance in that time frame. So in my opinion, power performance shouldn't be on the critical path. I think the duration test would be on the critical path and the power performance would just fall within it. In terms of data processing, I think it's definitely within the realm of Excel. You might need some array functions. And I guess if you're on a laptop or something, it might be a little challenging, or an older laptop, it might be a little challenging just in the computing power. The standard uses clear and well-defined equations. I don't think most people have any issues with the standard. Just an example, it just gives you the equation, what you're after, describes what the variables are. That said, there's enough detail. By the time you finish your Excel spreadsheet, you'd want to do some kind of checking. You'd want to, you know, maybe your certification body can do a round robin with you and say, hey, we've got this data set. We want you to do power performance or come up with your power curve with uncertainty on this data set and do some checking. I think it makes sense. I think although it's fairly straightforward and simple in some ways, there are a lot of details. The uncertainty portion is probably the harder piece. And I just have here that there's old NREL reports that have lots of details on their uncertainty analysis. And I remember, and I'm not sure they're still available, and I know our Linda put together some nice presentations around uncertainty. I think Joe Smith as well back at NREL. So there are somewhere in the universe, there's some good presentations around uncertainty analysis. Okay, so now at this point, we've collected our data, we post-processed it, we got our power curve and uncertainty analysis and that kind of stuff. We got to put together this final report. And we can go straight back to that standard, -12, and it has a whole section on what needs to be in the report. Again, just laid out step by step. So I think it's really good. The standard's really good in just stepping you through this process. And then we have this added bonus of NREL's got great templates out there. You can go look at the Swift power performance or various power performance reports that they have online. And a lot of ways I just say, you know what, those are excellent reports. I want to just make my report look like that. And just as an example, I hear here that it's kind of in the 50-page range, where about half of that is really presenting the data and maybe describing details about the site and the turbine. And then the other half is appendices, kind of around maybe the site analysis and calibration reports and stuff like that. Here's just an example. I pulled this off of another presentation I did, but here's a power curve. And from my experience, this is 19 days in. From my experience, after about 5 days, maybe a week or something, the power curve is fairly stable. I mean, the first day, it's not smooth. It's got, it's just not a smooth curve. And then the second day, it's getting smoother, third day. And like by the 5th day, it's pretty smooth. It's typically, I haven't found it changes much after that. But you keep going because you haven't met all the requirements. You maybe still have some holes in the power, at certain wind speeds. But again, just as an example, this is 19 days and we've got 224 hours of valid data. So we've exceeded the 180. This happens to be a larger turbine. So we've exceeded the 180. So we're good on that. But this power curve is not rolling over, which is going to be a problem on how much wind I need to get on the high end. And as I said here, I only have half an hour in the 17 meter per second bend. So this test is going to keep going because I really need better definition on the high end. I need to hopefully see that power curve roll over, and then that would define how much data I need further out beyond that. So this is just an example of plenty of total hours, probably have the required 30 minutes per bin, but not good on the high end. And that's somewhat typical. So moving on to acoustic testing. The good news is most of the instrumentation now is in place, assuming you've kind of set up around power performance. And the test times are much shorter. Bad news is there's some serious challenges around the data collection. The post-processing is a magnitude harder, I think, than power performance. And you do need some new expensive instrumentation. So you need a microphone, you need an acoustic calibrator, you need that soundboard, you need various other pieces of equipment that you don't have after just doing power performance. As we saw in the -12 standard, the acoustic standard has an Annex F for small turbines. So that's for turbines that are less than 100 kilowatts. And it kind of gears it towards that. Here we need to go cut into 11 meter per second minimum. They're 1 meter per second bin widths. And then it has in the standard, if possible, up to cutout. I could see how what they want to do there is, if you've got a turbine that furls, or a turbine, small turbine that furls, or a small turbine that flutters or something, 11 meters per second might not capture its total acoustic signature. So in that situation, you might want to go higher. Measurements are pretty short, 10 seconds each. And again, 1 meter per second bin widths. And we want 12 measurements for each bin with the turbine operating, and a minimum of 12 for the background. So with the turbine stopped. And as you can tell, it's not a lot of data. And more likely you can collect this in weeks, not months. I think for me, typically, it's about a week, maybe a little longer. Sometimes I struggle to get certain wind speeds. The microphone, as I mentioned before, needs to be downwind of the turbine. And when you're dealing with larger turbines, that sector is kind of tight, plus or minus 15 degrees. When you're dealing with smaller turbines, they kind of open that up, understanding that they're probably much more dynamic in yaw. The measurement chain needs to be calibrated before and after each measurement. Ideally, you want the same conditions, but the background noise when it needs to be measured. I've run into situations where I'm testing in the winter and I don't have snow on the ground, and then I have snow on the ground. And it's kind of like, well, those are kind of different situations acoustically. And then it has to be quiet. That's probably one of the bigger challenges, is you can't have people and traffic and birds and planes and trains and grass and crickets and everything. And the first time I went out and did acoustic in the middle of the night, I was just shocked that everything was making noise. It seems like in the middle of the night, it'd be quiet, but I have a nearby highway, and it's amazing how far I can, in the distance, I can hear those trucks. And this picture is these vents on a nearby building. Never thought anything of it, but out there at 3 in the morning, those vents are just flapping up and down in the wind. It just makes me realize we really live in a noisy world, and just we kind of accept it. It's just the norm at this point. In terms of post-processing, I've used Noise Lab. I'm sure there's other software that's basically going to take that recording and then convert it to data. I say here, for full automation, you probably want to be programming in something other than Excel. I've built my spreadsheet in Excel, but it really does take my computer. It's maxes out my computer. Actually, for many years, I kept an old version of Excel because I just, for some reason, it ran much faster than the newer version. So that can be a challenge. Again, as is the case with the power performance, I think the standard uses clear and well-defined equations, but the equations are much more complicated. I mean, if you compare the CP equation I showed before and this one, it's like there's multiple subscripts on this, and there's raised to the power and summations and stuff. So the equations definitely get more complicated in the acoustic world. I have here, interpretation of words can be challenging. So while we were doing some round robin work one time, in my opinion, there was a sentence that told me to use this equation, but that came up with a very different result. And then when the certifying body said, no, that sentence doesn't mean that, I agree with them. I think they were doing it the correct way, but to me, that sentence did not say to use it. To me, it said use the equation I was suggesting. So there are some areas in there where just the words can lead you down the wrong path type of thing, even though the equations are well defined. And then I think it doesn't help. Most of us don't have a strong background in acoustic analysis, where I'm just trusting that that's the right equation. It's like I don't have any good judgment on whether I should be using that equation or this one, because it's all a bit black magic to me type of thing. So I say, if you're going to do the post-processing yourself, again, you'd absolutely want to do some validation work around your analysis compared to someone else's analysis, or kind of a round robin situation. Tonality is laborious and requires lots of manual clipping. In a lot of ways, that was the most unpleasant part of doing acoustic, and maybe the most time consuming. But like a lot of work that came out of the ACP 101, that's not required anymore. They do recommend that if there's an obvious tone or something in the turbine, that it get mentioned in the acoustic report. So that's good news. No one wishes that upon others. And I have here significantly more difficult than the power performance data post-processing. On to the duration test. So purpose outlined from the standard is structural integrity, material and performance degradation, quality of environmental protection, and dynamic behavior. And I think that is true. That's kind of somewhat what we're after. I think everyone recognizes that the duration test will capture infant mortality kind of stuff. Does it suggest it's going to last 20 years? I think we'd all agree it doesn't suggest that. But it gives us some basis to say this turbine operates correctly and not in some crazy fashion type of thing, and that it can handle some amount of variable input, from the wind type of thing. So the next list on the requirements, I've outlined what used to be the case within the AWEA standard. And then again, ACP, one of the goals of the ACP 101 was to really reduce the labor and effort and costs associated with certification. So a lot of these numbers have been knocked down quite a bit. So used to be this requirement about greater than 90% availability. That's been removed. At least 6 months of operation, that's been removed. It used to be 2,500 hours of power production. Now that's 1,000. It used to be, and this was probably where most people got caught up in these higher winds. I know Brent's done a presentation where some manufacturers that were going for a class 1 and they could just never get these high winds. And here I've given you an example of, it used to be 250 hours above 1.2 VAV for a class 2. That's 250 hours above 10.2 meters per second, or 25 hours above 15.3 meters per second. And 15 greater than 15 meters per second. Well, now the 15 is 10 hours greater than 15. So again, the goal of ACP is just to not keep people stuck in this duration test because they can't fill these higher wind speeds, as an example. Major failure will restart the test. That's consistent before and after. And this operational time fraction analysis of power degradation, which was required, is no longer required. And my little bubble over there, no new instrumentation needed. Again, if you've set up for power performance, you've got all this data coming in and you're just collecting more data. Safety and function. You want to go through and look at the OEM procedures and other manuals. You kind of want to take a look at that, evaluate whether it's appropriate, review personal safety topics. So if the turbine's something you would climb, does it have proper warnings and safety labels, and then kind of a little bit of analysis or a check on the safety related around climbing. The function side is really kind of similar to a commissioning procedure, but we're going to collect some data while we're doing that. We're going to just make sure on a grid fault, does it properly shut down or get to a parked condition or idle condition. And we might pull a sensor, an RPM sensor or something. Again, just making sure it has a proper control system to put it in a safe condition. Might want to run some specific events like high wind startups or high wind shutdowns. And then ultimately, we're going to look through the data. We're going to look for this peak power, which is described in the ACP power limitation. We'll make sure it can limit its power, and then rotor speed, make sure rotor speed doesn't get crazy. I just threw a few plots in here. This is off a Whisper, but this was the highest. When I was doing some testing, the highest rotor speed just came out of a big gust that kind of started at 7 meters per second and bumped up to 18 relatively rapidly, and caught that turbine unfurled and got the rotor excited. So in terms of, this is the peak power analysis that comes out of ACP 101. So again, you got your power curve and you find your peak power, and then you go down to 95% of that value, and you find the wind speed, which in this case is 11.5. And then you want to have 10 1-minute data points in each 0.5 meter per second bin for bins that are 5 meters per second higher and 5 meters per second lower. So that's kind of what they're looking at. That's kind of the capture matrix required to say, yes, we've got enough data that we should have confidence that we've captured peak power. And this analysis would also demonstrate the power limitation, that power doesn't go crazy. In terms of max rotor speed, this is actually coming out of ICC-SWCC 61400-2. And there it talks about 2 hours of winds between 10 and 20 meters per second, where you have at least half an hour below 15 meters per second and half an hour above 15 meters per second. And within that data set, we just want to go look for the maximum wind speed, and then it says to extrapolate that out to this V reference wind speed. Mechanical load testing. This is not typically done for smaller wind turbines, although you might measure some loads, but typically you're not going to do an actual report or an actual mechanical loads test. It could be useful to validate some of the modeling, especially if you have a a non-typical turbine like a VOT or a ducted turbine. It is required for the larger turbine, the type certification. I have here, it's a significant undertaking. I think it's just expensive and time consuming. And you can use, again, your wind speed and temperature and pressure and all that is appropriate for this test. And now you're going to add loads. You're going to add tower moments, rotor moments, blade moments. To get stuff off the rotating reference frame, you're going to want split ring or some telemetry. We have a whole section on anti-aliasing modules. And then really to support some of the loads you're measuring, you're going to want rotor azimuth, yaw angle, etc. So lots of good information come out of loads testing. It's just, it is expensive and time consuming. Within the -13 standard, it talks about the minimum required data channels, and then it has a recommendation for additional channels. It talks about capturing these loads during transient loads like braking, high wind shutdown, grid loss, startup. They want lots of data around normal operating conditions. They have a range. They suggest, you want to capture this range of wind speed. And as I mentioned before, they do want some variability in the turbulence. They detail how to do the in situ calibrations. And then like the other standards, they talk about data processing and reporting. So kind of in summary, and again, I think there could, I put this caveat here that time and cost could vary significantly. And I think that's the reality. But from my experience, and again, these numbers are from a few years back, so they're probably low. But just to give you an idea of kind of what these costs pan out to be. And they are kind of assuming that acoustics not by itself, that the acoustics is really about collecting the data and processing the data and writing the report, not putting up the Met Tower. I keep assuming that most of the, that you've set up power performance, everyone wants to know the power curve. So you're going to do that test, I think, no matter what. And if you're set up for that test, you're well positioned in terms of instrumentation and data collection for these other tests. And here's just kind of focusing more on the certification stuff. And again, don't hold me on these numbers, and they are a few years old, but I have here 200-ish K for smaller turbines and close to that 900K. And these are somewhat aligned with the support that the CIP program is bringing to the table. And that's all I have.
Fantastic, Dean. Yeah, we've hit them hard with standard certification and testing today, but it's it's the right group though. Any burning questions for Dean before we go on a short break on testing? Yeah, Dean, I dug up a couple legacy reports, as you mentioned, that one that, from Joe, one from Arlinda, but just through some Googling, the question is if Dean has any additional legacy reports, that would be amazing. So if anyone wants to dig around, I don't have a tidy collection of them, but it's an interesting idea is to try to maybe do that.
I do on our website, which is just www.windwardengineering.com. I do have reports that we've created.
Right. Yeah, those are good too.
And we modeled around your guys' reports, so hopefully they're very similar.
Yeah.
But yeah, our Linda's uncertainty stuff, she had a few presentations, which I think were really good and talked about different assumptions in the uncertainty and which model should use and that kind of stuff. And I'm
Probably
not
back,
sure I've seen those in years.
yes, probably back when we had that the testing workshop
Mhm.
at various places like NREL and Texas. That was a few years ago.
It was, yeah. So
Okay.
maybe Jeroen can ask her. You
Yeah.
still have those.
Okay, great. Well, thank you very much, Dean. We're going to take a short break now, unless Heather has a question before we do that. I saw you pop up.
No, I was just gonna point out to people if they hadn't seen that link in the chat.
Oh, thank you.
That so many links have been shared with great information. And
So many.
Guru had a good idea of putting the Google Sheet together for contacts. And then we have another tab for all of these links that have been pasted into the chat. So
Excellent.
thank you, Guru.
Yeah, that's a great
And
idea.
It's going to be a nice resource moving forward.
Great collaboration. Appreciate the diversity of viewpoints here. It's very helpful. We're going to take a break it's 53, so we'll just go 7 minutes and right at the top of the hour, 4 o'clock Eastern US time, we'll start back. I've got some questions queued up from the chat to answer, and then we'll go briefly through design review evaluation before we wrap up today. So we'll see you in 7 minutes at 4 o'clock or 2 o'clock, top of the hour. All right, short break over. Grab a snack, warm up your coffee. We've got 16 members of our brand new LinkedIn CIP group. So I look forward to seeing posts and collaborations on there. Welcome back. Couple minutes here for questions before we get into design reviews, but to warm it up, I'm going to try to address some questions from the chat here. Good questions. Thank you, Dave Snowberg. We've heard a lot from Joe Sposey yesterday on listing of components to electrical safety standards, and today on turbine certification and the associated standards and testing to those standards for the purpose of evaluating your prototype and going to certification. So I realize it's a complex world to navigate. Here are some questions. How does the electrical standards presentation from yesterday overlap or not with the standards discussed today from me and Shawn? What's the market pull for certified equipment? For example, are certified turbines required to be sold into some markets, and if so, which standards? Great questions. But my short answer would be listing, which is what Joe talked about, listing the turbine system and components within the turbine system is a national electrical code requirement enforced by the authorities having jurisdiction in various areas. And unfortunately, as Joe presented yesterday, this varies quite greatly by state, but Article 694 for wind hasn't changed much recently, so it's leveling out. But still, it varies. California, for example, requires the inverter be listed to UL standard 1741 SB, the latest and greatest. Other states require SA, other states require just UL 1741, and the differences are considerable between these. Turbine certification, which we're talking about today, is for lots of reasons, as I articulated, but mainly is used for incentive eligibility. Like, for example, the IRS tax credits, which I showed, and state incentives, which are variable as well. They come, they go. And therefore, turbine certification has been seen as optional, because maybe you can sell your turbine to a market and the customers don't want that incentive. But the incentives are so big right now, where 96% of the capital costs can be covered by grants and incentives and tax credits, that it's probably not the case. So If you want to get in that market, you're probably going to want your turbine to be eligible for the incentive. So identify the target markets, determine the listing requirements enforced by that market for obtaining a permit, and B, what incentives are available and their eligibility requirements. Which standards should a developer focus their efforts and why? UL 6142, ACP 101, IEC-2. So the NEC requirement says list the turbine system and components, and it shows UL 6141 for turbines you can get inside of, and UL 6142 for small turbines. And within that, there's lots of component level standards, and that's for getting your permit, because your AHG is going to want the equipment to be listed. Incentive eligibility requires the turbine be certified to industry standards. And for example, the IRS tax credits say it can be certified to OEA 9.1 or the IEC standards or ACP 101. So they have various pathways into that eligibility. And then how does SWCC relate or differ than IEC-RE? All these certification bodies are accredited to ISO 17065, a global accreditation system for certification bodies, but it's more about what they offer. ICC-SWCC offers small wind turbine certification to ACP 101-1, and medium wind turbine certification to the IEC standards, therefore giving the turbine eligibility for the IRS tax credits. This has always been intended for the North America market, but there's nothing stopping Taiwan or Brazil or anyone from putting in ACP 101 as a pathway to eligibility for something. Whereas IEC-RE is a global type certification system per the IEC standards. It costs more. You work with different certification bodies that are members, and it's intended to provide a global market acceptance. Hasn't gained a lot of traction yet, but because the turbine manufacturers are saying, I'm going to sell to the US, let's do what they need. And then I've got these portable test reports maybe, and let's do what Japan needs so I can get in that market. Now let's do what the UK needs so I can sell into the micro generation certification scheme. So they've been targeting these a few national market requirements instead of going for one globally accepted type certification in general on the small end of turbine scale. So I know this is all kind of difficult to navigate, but this is how I see it. You know, there's optional and there's non-optional certifications, but we are trying to produce a distributed wind certification best practices document NREL with subcontractor RE innovations coming in early 2024 to help navigate this. But that's my short answer. Any clarifications, rebuttals, or further questions?
Thanks, Brent. That was helpful.
Okay, thank you, Dave. Some of this gets lost in the acronym soup, and it's good to step back and have a big view. If you have another question, bring it. Otherwise, I'm going to switch to our final dose of technical slides here on the design review and evaluation part of CIP. I'll keep it brief, but this presentation is a good resource. Another good question in the chat before I get started was from Paul Rowan. And when do we get these PowerPoints? Well, we can promptly post the recordings on the CIP website. Posting the PowerPoints takes longer. It has to go through NREL publication process, and there's some uncertainty with the non-NRELian presentations. Paul, if you want Dean Davis's presentation or information within, the quickest route to get it is to contact Dean Davis at this point. And I'm sorry if that becomes a hassle, but I think that's where we are. Anything else? All right, let's talk about this. Thanks to Rick Damiani and Robert Preuss, both former NREL-ians and active in distributed wind, small wind, medium wind, floating wind, and specifically CIP in previous years for some of the help in this presentation. Here are topic areas requiring a design evaluation or a design review where you work with NREL and other DOE lab folks to go over the design of your turbine system. Prototype design development has a concept design evaluation. Prototype testing topic area has a design evaluation. The small turbine certification has a design review. And there's no difference here between design evaluation and review. I think it's just some semantics. Type certification has a design evaluation, and so does the prototype manufacture and installation topic area. An overview of what we're talking about here. We want the design of a wind turbine is the process is described in an informative note within NCACP 101-1. Okay, design loads. These are the forces on the wind turbine as it interacts with the wind and gravity and other forces. Design loads are obtained through either calculation, simulation modeling, and or direct measurement for a variety of load cases. Tomorrow, we're going to have a great presentation from consultant Drew Gertz on the various design tools to get these design loads. For a variety of load cases, which are a set of design situations covering the most significant conditions which the turbine system may experience in its life. So that's tricky. You know, what are the loads on the turbine components is hard to get, and a lot of the effort here is estimating those loads. And then safety factors are applied to these loads, and the mechanical strength of the major components is evaluated considering the material properties, the ultimate loads, and the fatigue loads. Good old mechanical engineering here. The maximum operating load as predicted by the design calculations or modeling is physically applied to the rotor blade in the static blade test to verify blade strength and deflection. It's the one mandatory component test that checks the deflection and strength of the blade. Okay, so the prototype design development topic area, you come in quite early. You know, one of the early deliverables is prepare yourself for the design evaluation. So it's directed by NREL using subject matter experts in-house and from other DOE labs. So if it's, for instance, if it's a vertical axis turbine, we'll look to some folks in Sandia that have expertise in this area to join us. Or if it's an inverter going through listing, we'll look for folks with experience there at other labs to join us as we go through the design evaluation. The evaluation in this prototype design concept will include the technical concepts of including load estimations, the performance estimation, cost assessment, and then responding to questions from the experts. The intent here is to show the work done and get feedback. It's a collaborative effort, and you always come out better on the other end. And the intent here is to ensure that the turbine or the component is ready to progress to the next step, producing a prototype. And looking even further out into the future is potentially technically and commercially viable product. It's expected that there are technical problems and challenges identified at this stage. And then part of another deliverable is a report on addressing some of these identified problems and challenges. You don't have to solve them all, but if they all appear to be solvable and the concept is otherwise viable, then the project is approved at the go, no go decision gate. So the prototype manufacturer installation, very similar. And here It's the, is the turbine ready for prototype construction? So look at all the loads, look at the engineering done, and do we have confidence that you're ready to build this prototype? Also, the intent of this review is to ensure that the turbine in the current configuration is mature enough design for certification testing and manufacturing production, and that it meets market requirements to be competitive. So again, looking out into the future, is this a viable product? Will it be too expensive? Will it be able to be certified? Is it looking like it's ready to be manufactured for prototype testing? Very similar to prototype, the previous topic area. For the prototype testing topic area, all the same applies, except we want a little more details on your planned testing efforts. Tell us where you're going to do the testing, what you're going to measure, what you're trying to learn from the prototype testing as part of this design evaluation. The intent here is to ensure the turbine will benefit from prototype testing in its current configuration, and then will subsequently be positioned for certification testing. Now, if you're applying for a small turbine certification award, then that implies you're ready to go into certification testing and certification. Now, this design review doesn't say, hey, you're certified by NREL. It just says, okay, we've gone through the design review and it looks like the turbine to be tested for certification is likely to pass. The design is likely to be certified if the field tests are completed successfully. It's essentially a trial run or some preparatory stage for handing over your design file to the certification body. So it's pretty good benefit. Usually you work in-house, calculation, simulation, modeling, mechanical engineering, and then you've got to convince the certification body. Here, you've got to go through NREL first, get some feedback, improve things before you get to go to the certification body, which is a benefit. Essentially, what you're doing is what -2 calls a preliminary version of the limit state analysis. Show us how you got the loads, show us the how you did the strength analysis on the major components. We'll do a go, no go decision on, is this likely to pass certification? Oh, and then, when you get to the certification body step, they'll do a more rigorous review, checking the design drawings, going to the shop floor for a factory inspection, and then checking, confirming that the loads were adequately estimated. If you're, this topic area also can include listing to electrical safety standards. For that, in that case, the design evaluation consists of a review of that equipment, the power converter, the inverter, the controller, whatever it is, and the documentation that will be required by the NREL, the nationally recognized testing laboratory for which you plan to interact with for listing. So a little different, a lot of this details in this presentation are concerning turbine design, loads, limit state analysis, and subsequent certification and testing. Listing's a little different, but the process is similar. Show us your design, construction review. Is everything, all the components in there listed to component level standards? They'll put the unit, the inverter under test, produce test reports, and then work to grant certification that it can be listed and meets the requirements of the standard. So similar process overall. Type certification is a little different. Here we take, as an initial go, no go determination, we take the design basis evaluation, which was performed by the certification body as the first, we'll review that document for the first go, no go. And then, so that's kind of like an initial preliminary assessment, but we count on that certification body's design basis evaluation for that. And then we do another go, no go after the certification body completes the design of the full design evaluation. And then at the end, the conformity statements from the certification body are sent to NREL. So here we rely greatly on the certification body's work for our go, no goes. So what to include, details about the control system. As you see in the standard, it describes the protection system shall be designed to be fail-safe, protect the small wind turbine from any single failure or fault in a power source or a non-safe life component, do some testing, do some analysis to verify that your control and protection system will maintain safe behavior for the turbine. Design load cases, take the time to understand all the wind and fault conditions that the turbine will see. List all the assumptions of the components, provide clear commentary with references to any assumptions made, and describe the modeling or the methods used to determine the loads, which we'll hear about from Drew tomorrow. And the loads come from interaction with the wind, aerodynamic forces, inertial forces, vibration forces, seismic, gravitational, and operational due to yawing, furling, grid faults, and so on, plus transportation, ice, wake, and maintenance loads. So lots of things to simulate or calculate here to get your loads. And the minimum set of design load cases, situations that will provide loading on your turbine: power production, normal power production with a fault, shutdown, emergency shutdown, manual shutdown, extreme wind and high winds that come every 50 years, extreme winds that come every year in a parked or fault condition, and then what are the loads when it's being transported or assembled or maintained and repaired. Those are the minimums. There may be different ones for your turbine, your particular design. And then you're like, okay, here's all the loads from all the design load cases, and you have this table of simultaneous load components for assessing the ultimate limit states, the forces on the major components and the resulting deflections and strains, and the fatigue limit states from that years and years of normal operation results in a design equivalent load. And you apply here the partial safety factors, and then you plot and analyze the loads on each component from all the design load cases, and you identify the design driving loads on that component, and you perform your mechanical engineering. It shall be verified that limit states are not exceeded, so that ultimate load on that component or that fatigue load is not going to break the major component within, or cause it to fail within its stated design life, typically 20 years. So you have to do a modal assessment to assess the vibrational loads and avoid and look for potential resonance where the excitation frequency from the wind turbine may coincide with the natural frequency of the component, leading to resonance and damaging oscillations. And you can see that by generating a Campbell diagram overlaying those natural frequencies with the excitation forces of the spinning rotor. Software can kick that out, and then you can easily show various arrangements and how you're avoiding dangerous resonance. If you identify potentially dangerous resonance, then you can address that in the design. You evaluate all the major components: the blade root, root hub connection, the hub, main shaft bearings, and yaw shaft, as specified in ACP 101, and then all the components in the IEC standard certification. And for each components, you include the eigen analysis, which is the vibration analysis, finite element analysis, at a minimum equivalent static loading to that major component. So good software there for finite element analysis as well. Explanation of the boundary conditions and the assumptions, material properties, safety factors, manufacturing processes, and then finally that static load test is required, but except unless you're a micro wind turbine under ACP 101. And we recommend you take this report, which again, it's your report that you're building. We call it, the world calls it the design file. You're building this report to hand to a certification body to convince a third party that your gear is engineered and will hold up. for the design evaluation as part of CIP, we recommend taking that information and putting it in a PowerPoint presentation so we can go through the loads, the engineering, the controls, slide by slide, ask questions back and forth, and resulting in some follow-up perhaps, but as opposed to trying to go through a Word document type report, which is a little more arduous. So some takeaways here. You know, it's by no means has all the details you need to do a design evaluation, but it gives you a little flavor of what you have to be prepared for. I mean, some companies have internal resources that do this. Some companies hire consultants. Even the certification bodies will often hire a consultant to perform a review of the design file. But we are, you're fortunate if you're part of the CIP topic area that requires a design evaluation to sit down with some veteran engineers, pick through your design file, ask questions, and improve things. But the takeaways are, you know, read and understand the standards, or, you know, find someone that can help you do so. Be scientifically rigorous, convince the reviewers of the choices made, and prove it is a safe and reliable design. Right. Classic engineering. Pay attention to the documentation format, stay organized, use your best engineering judgment and document that and support assumptions, and be prepared to be asked for more clarification, perhaps tests and proof. And this design evaluation is required by NREL for a go, no go as you move forward in your project. I'm not going to go through this, but we've provided a design analysis report outline. We include this and share it with you as a CIP recipient, but it's in here as a bit of an annex. Okay, we made it briefly through that, and we have a few minutes left for questions about today's topics. Thank you very much for your attention. Okay, how's it going out here? Are you guys still alive?
Hey there.
Is anyone still here? I just see a bunch of names. There you are. So pop
Still
in,
alive.
say hello, prove that you're still here as we work to wrap it up for today. I know a lot of technical information came out today, but hopefully you liked some of it, and hopefully we are clear enough. But any questions?
No, Dr. Brent. Doug from Apposite here. Quick question on that last bit you were looking at. Are those, the criteria that I outlined, is that available before being awarded a CIP, or is this something you would only get after the fact?
Yeah, we're happy to share that with you, Doug. It's not a secret.
That'd be great. Yeah, cool.
Happy to share.
Yeah, drinking from the fire hose, looking to get all the information you can.
Yeah.
So
we don't have these PowerPoints posted, as from last workshop. We only have the recordings, but my intent is to try to get them up there, but I'm happy to share this outline or any information you need. Just reach out.
Awesome.
Okay, Robert, you got the LinkedIn work going? You can't search for it because NREL wants it to be private and unlisted. So I have to invite you or give you the link. And so I'm glad you checked it. You can't find it.
I got it.
Secret club, welcome.
Erica helped me out. She put it up and I just clicked on that. It went.
Okay, wonderful.
That helped me as well. Thank you. Brent, you showed yesterday that in a presentation, perhaps it was Ian, an outline of a kind of letter of intent.
Yes.
Sort of, in the absence of getting those slide decks out, could you some find a way to kind of share that around?
Yeah, my initial plan A was to have this template available now, but it's not quite ready yet. So
Oh.
plan B was to contact everyone here and the whole CIP list with the request for concept papers, including that template. But yes, in the interim, I can share that basic outline of what we're looking for, so you can go ahead and get started.
That would be helpful, yeah, just
Yeah.
get the wheels turning and maybe
Yes,
make some contacts for prospective partners.
right. But
Which,
essentially, it's like, give us, briefly give us an idea of what you're thinking. And so it's like, well, we're gonna certify our wind turbine. SWCC is gonna do it, and we're gonna test it at Dean's site, something like that. But we do have an outline, and I'll try to pull it up real quick, and you can grab it.
I'm gonna say there's no restriction on screenshots.
Nope, not at all.
If we had thought about it when you had it up yesterday, you could have snagged it then.
And we're talking about it again tomorrow to see if there were any
Oh, good.
questions.
I'm still trying to deal with links in chat boxes, and then when we hang up, they're all gone, and I don't know.
Good point. Oh, here's a little tip. I think the little 3 dots at the bottom is the save chat. If you do that right before it ends, you get everything.
Oh,
Oh,
really?
yeah. Save your chats. That's a good
Save
idea.
your chat,
The chat
but then you
says-
got to go back and dig in them. So
Okay, let's see if I can get my.
is this the one you were thinking of, Paul?
It is, thank you.
Ah,
Although my
sweet.
snippet tool doesn't seem to be working, why not?
Okay, I can email it to you.
Yeah, and I'll
If
copy
I'm not
it
an
here.
NREL employee, I can.
Well, that would be wonderful, because
Sure. In fact, I can
Oh.
paste it into that Google sheet.
that
Anybody
would
want?
be- that would be-
Here we go. Even better.
And the idea is, get this out in December, which is Friday, but the concept paper request, get them in January, review them, get feedback, and then hopefully have a solicitation in February. So it's December, January, February is sort of, here we go. Get prepared for the next one.
Cool. Yeah, I think that'll be helpful. That's a good idea.
Right.
Very good.
Thank you, Heather. I have it now.
Oh, cool. The wonders of computers.
We're out of time, but hey, I'm open for another question if there's a burning one or comment.
I
Well,
just want to
thanks.
say thanks for putting this on. It's been really useful, a lot of good info.
Yeah, well, we'll look forward to seeing you guys tomorrow. Come back for Kendall Jackson from NREL Procurement. We'll go through that official stance on the procurement process. And then Drew Gertz, he got moved to tomorrow because he's in an airplane right now. He'll talk about design tools for distributed wind, and then we'll clean up with additional CIP considerations, including tech support, technical assistance opportunities, and then end the day with a little discussion about CIP.
I do have one quick thing. I'm sorry if you covered it yesterday, but you already know how much money is being released for FY24 and like roughly the total number of awards you might be able to give out this cycle?
It's a normal year, so it'll look a lot like 2021 and 2020. 2022 is a little weird because we doubled down and so we could award more awards. But it should be a
So there wasn't any roll forward
similar.
from 2023? No.
No, we used 2 years of funding and basically in 2022 and took a year
Sure.
off and applied any balance we had there to existing active projects to keep things moving.
So it sounds like probably roughly 8.
That's a good guess.
Okay, sounds good.
Yeah.
Well, I wish there was more.
I know. We always get way more proposals than we have money, and that's the main problem. So hence it's competitive.
And of course, right now, there is no 2024
Approved
budget for DOE. So
Right.
that could impact things both positively or negatively, depending on how things break down.
Yeah, that's why we're cagey, because we also have to go, this has to go through a DOE go, no go. Do we have funding? Are we going to do this? And so we have to go through that as well. But so far it's looking good. I'm excited. I hope, hope things continue to roll as they're rolling.
Cool.
All right. Thanks, everyone. Have a great night, and we'll see you tomorrow, hopefully.
Very good. Thank you.
Bye-bye.
Good night.